Welcome to MindTier Learning, where we make GCSE learning and revision simple. This presentation is designed to make your study process more straightforward and effective, helping you to prepare confidently for your exams. We'll explore useful strategies, tips, and resources that will support your learning and revision journey. Let's get started. Welcome to today's lesson on landforms of the upper course. In this lesson, we are going right back to the beginning of a river's journey, the source. The upper course is usually found high up in the landscape, often in hills or mountains. This is where the river begins, and because the land is steep, the river has a lot of energy. However, the river is usually quite small at this stage. It has not yet been joined by many tributaries, so its discharge is low. Discharge means the amount of water flowing in the river. Even though the river is small, it is powerful because it is flowing down a steep gradient. Most of its energy is used to cut down into the landscape. This is called vertical erosion. Today, we are going to look at the main landforms created in the upper course: V-shaped valleys, interlocking spurs, waterfalls, and gorges. The big question for today is, how does a small river high in the mountains create such dramatic landscapes? Let's begin with the learning objectives. By the end of this lesson, you should be able to do three main things. First, you should be able to explain the role of vertical erosion in shaping V-shaped valleys. That means you need to understand how a river cuts down into the land and why the valley becomes narrow and steep-sided. Second, you should be able to describe how interlocking spurs are formed as the river winds through the upper course. Interlocking spurs are ridges of land that stick out into the valley from either side. The river winds around them because it does not yet have enough power to cut straight through them. Third, you should be able to detail the sequence of events leading to waterfalls and gorges. This is very important for GCSE Geography because waterfall formation is often tested as a process question. You need to know the correct sequence: hard and soft rock, erosion of soft rock, undercutting, plunge pool formation, collapse, retreat, and gorge formation. So, by the end of the lesson, you should be able to explain not just what these landforms look like, but how they form over time. Before we go any further, let's go through the key vocabulary. The first key term is vertical erosion. Vertical erosion means downward erosion. It happens when the river cuts down into its bed, making the river channel deeper. This is the dominant type of erosion in the upper course. The second key term is interlocking spurs. Interlocking spurs are mountain ridges that overlap from either side of a river valley. They are sometimes described as looking like the teeth of a zip because they stick out alternately from both sides. The third key term is nick point. A nick point is a sharp change in the river's long profile. The long profile means the shape of the river from source to mouth. A waterfall is a common example of a nick point because it creates a sudden drop in the river's course. These terms will help us explain the landforms properly. Remember, in GCSE answers, using key vocabulary accurately can help move your answer from a basic description to a strong explanation. Let's start with a quick recap. In the previous lesson, we looked at how a river changes from its source to its mouth. This is called the long profile of a river. The long profile usually starts steep in the upper course and becomes gentler as the river moves downstream towards the sea. In the upper course, the river is high above sea level. This means it has a lot of potential energy because gravity is pulling it downhill. However, the river is still small. Discharge is low because not many tributaries have joined yet. The river also carries a large, angular bedload. Bedload means the material carried along the riverbed. In the upper course, this material is often large and rough because it has not yet been broken down into smaller, smoother pieces. This large, angular bedload creates friction, but it also helps the river erode its bed through abrasion. So the upper course is a place where the river is small but powerful. It is using gravity and its rough bedload to carve into the landscape. Now let's check your understanding of downstream changes. Question 1. What happens to the gradient of a river as you move downstream? Question 2. How does the size of bedload change from the upper course to the lower course? Question 3. Why does velocity often increase downstream despite a flatter gradient? Take a moment to think about each answer. Remember, the river changes as it moves from the source to the mouth. The channel becomes wider and deeper, the bedload becomes smaller and smoother, and more water joins the river from tributaries. Let's go through the answers. For question 1, the gradient becomes less steep as you move downstream. In other words, the river profile becomes gentler. For question 2, the bedload becomes smaller and more rounded. This happens because rocks collide with each other in the riverbed as they are transported downstream. This process is called attrition. For question 3, velocity often increases downstream even though the gradient becomes flatter because there is less friction. In the upper course, the river channel is shallow, narrow, and rough. This creates lots of friction, which slows the water down. Further downstream, the channel becomes deeper, wider, and smoother. Discharge also increases because more tributaries have joined the river. This means the river can often flow faster, even though the land is less steep. This is a key idea. River speed is not controlled by gradient alone. It is also affected by channel shape, friction, and discharge. Now let's focus on gravity. Imagine a river starting 800 meters above sea level. Its journey is downhill towards sea level. Because the river is high up, gravity gives it energy. The steep gradient means the water flows downhill with force. In the upper course, most of that energy is used for vertical erosion. Vertical erosion means cutting down into the riverbed. The river deepens its channel by using erosion processes such as hydraulic action and abrasion. Hydraulic action is the force of water hitting the bed and banks of the river. Abrasion is when rocks carried by the river scrape and grind against the riverbed, wearing it away. But why does the river not erode the sides of the valley very much yet? The answer is that the river has a narrow channel, low discharge, and a steep gradient. Its energy is focused downwards rather than sideways. It is trying to cut a path down through the landscape. This is why upper course valleys are often narrow and steep-sided. Now let's look at how V-shaped valleys form. A V-shaped valley is one of the most common landforms in the upper course. The process begins with vertical erosion. The river cuts down into the landscape, creating a deep notch. It does this through hydraulic action, where the force of the water breaks material away, and abrasion, where the river's load scrapes along the bed. As the river cuts down, the valley sides become steep. Next, weathering acts on the valley sides. Weathering is the breakdown of rock in place. For example, freeze-thaw weathering may weaken the rock on the slopes. Once the slopes are weakened, gravity pulls material downhill. This is called mass movement. Examples include slumping, rock falls, and scree moving down the valley sides. The fallen material enters the river channel. The river then transports this material away, which keeps the valley narrow and allows the river to continue cutting down. Over time, this combination of vertical erosion, weathering, and mass movement creates a valley with a narrow bottom and steep sides. That is why it is called a V-shaped valley. Now we are going to look at interlocking spurs. In the upper course, the river is not usually powerful enough to cut straight through hard ridges of rock. Instead, it winds around them. These ridges are called interlocking spurs. They stick out from either side of the valley and appear to overlap when you look down the valley. This is why they are described as interlocking. A useful way to imagine this is to think of a slalom skier. A skier does not crash straight through the gates. They weave around them. In a similar way, the river weaves around the harder ridges of land. Interlocking spurs form because vertical erosion is dominant. The river is mainly cutting downwards rather than sideways. It has not yet developed the lateral erosion needed to cut through the ridges. So the key explanation is, the river lacks the power to erode laterally through hard rock, so it winds around the ridges instead. Let's check your understanding. The question is, why does a river wind around interlocking spurs rather than cutting through them? Is it 1. The river has too much energy and moves too fast? 2. Vertical erosion is dominant, and the river lacks the power to erode laterally through hard rock? 3. The river is carrying too much fine sediment which blocks the path? 4. The gradient is too flat in the upper course for the river to erode? Take a moment to choose your answer. Think carefully about the difference between vertical erosion and lateral erosion. In the upper course, which one is dominant? The correct answer is 2. Vertical erosion is dominant, and the river lacks the power to erode laterally through hard rock. This is why interlocking spurs are found in the upper course. The river is energetic, but its energy is focused downwards. It cuts into the riverbed, creating a narrow, steep-sided valley. It does not yet have enough lateral erosion to cut sideways through the ridges of harder rock. So instead of cutting through them, the river takes the easier route and winds around them. This helps us understand the shape of upper course valleys. They are narrow, steep, and often winding because the river is adjusting to the resistant rock and steep terrain. Now let's move on to one of the most dramatic upper course landforms, waterfalls. Waterfalls often form where a river flows over bands of hard rock and soft rock. The hard rock is more resistant to erosion. The soft rock is less resistant, so it erodes more quickly. At first, the river flows over both rock types. But over time, the soft rock is worn away faster. This creates a step in the riverbed. As water falls over the step, it hits the soft rock below with force. This causes hydraulic action. The force of the falling water, along with swirling rocks in the plunge pool, erodes the soft rock further. The swirling rocks cause abrasion, grinding away the rock like sandpaper. This creates a deep hollow at the base of the waterfall called a plunge pool. As the plunge pool deepens, the soft rock is undercut. This leaves the hard rock above sticking out as an overhang. Eventually, the overhang becomes unstable because it has no support beneath it. That sets up the next stage, collapse. Eventually, the hard rock overhang collapses into the plunge pool. When the hard rock collapses, the fallen rocks do not just disappear. The river uses them as tools for further erosion. They swirl around in the plunge pool and increase abrasion, making the pool deeper and helping undercut the soft rock again. This process repeats again and again. Soft rock is eroded. An overhang forms. The overhang collapses. The waterfall retreats upstream. As the waterfall moves backwards, it leaves behind a narrow, steep-sided valley. This valley is called a gorge. A gorge is found downstream of a retreating waterfall because it marks the former position of the waterfall. So a waterfall is not fixed in one place. It gradually moves upstream over time through erosion, undercutting, and collapse. The key idea is, waterfall retreat creates a gorge. Now let's put the sequence of waterfall retreat and gorge formation in the correct order. Here are the events. The hard rock overhang collapses into the plunge pool. The waterfall moves upstream, leaving a steep-sided gorge. The river flows over hard rock onto soft rock. Undercutting creates a plunge pool and an overhang. Think about the process from the beginning. First, the river needs to flow over hard rock and soft rock. Then the softer rock is eroded more quickly, creating a step, a plunge pool, and an overhang. Then the unsupported hard rock collapses. Finally, the process repeats and the waterfall retreats upstream, leaving behind a gorge. The correct order is: first, the river flows over hard rock onto soft rock. Second, undercutting creates a plunge pool and an overhang. Third, the hard rock overhang collapses into the plunge pool. Fourth, the waterfall moves upstream, leaving a steep-sided gorge. This sequence is very important for GCSE exam answers. A strong explanation might sound like this. A waterfall forms where a river flows over hard rock onto softer rock. The softer rock is eroded more quickly by hydraulic action and abrasion, creating a step and a plunge pool. As the soft rock is undercut, the hard rock above forms an overhang. Eventually, the overhang collapses into the plunge pool. This process repeats, causing the waterfall to retreat upstream and leaving behind a steep-sided gorge. That answer is strong because it uses key terms and explains the process in the correct order. Let's pause and think about the upper course as a whole. The upper course is a landscape shaped by high energy, steep gradients, and gravity. The river is high above sea level and is trying to cut its way down through the landscape. The dominant process is vertical erosion. This vertical erosion creates narrow, steep-sided valleys. Weathering and mass movement then help shape the valley sides, producing V-shaped valleys. The river winds around harder ridges of land, creating interlocking spurs. Where the river flows from hard rock onto soft rock, waterfalls can form. As waterfalls retreat upstream, they leave behind gorges. So even though the river may be small in the upper course, it has a major impact on the landscape. It carves the first path that the river will follow downstream. Now let's apply what we have learned to a more challenging question. The question is, if the climate became significantly wetter, what would happen to the rate of V-shaped valley formation? Consider both river erosion and valley side mass movement. This is asking you to think about how a change in climate could affect river processes. If the climate became wetter, there would likely be more rainfall. More rainfall would increase river discharge. That means more water would flow in the river. With higher discharge, the river would have more energy. This could increase vertical erosion because the river would be able to erode its bed more powerfully. Higher discharge could also increase abrasion. If the river carries more sediment, that sediment can scrape along the bed and deepen the channel more quickly. But we also need to think about the valley sides. More rainfall can saturate slopes. Saturated slopes are heavier and less stable. When the ground becomes waterlogged, it is more likely to move downhill under gravity. This means mass movement could increase. There may be more slumping, landslides, or scree moving into the river channel. The river would then transport this material away, helping to maintain steep valley sides. So a wetter climate could speed up V-shaped valley formation by increasing both river erosion and mass movement. You might have said that increased rainfall would boost river discharge. That is correct. Higher discharge gives the river more energy, which can accelerate vertical erosion. You might also have said that higher discharge increases abrasion rates on the riverbed. That is also correct. More water and more transported material can increase the river's ability to cut down into the landscape. You might also have explained that saturated slopes become unstable. When slopes are saturated, they become heavier and weaker. This can trigger mass movements such as slumping or landslides. The conclusion is that the valley would probably deepen and widen more rapidly. A strong GCSE answer might say, if the climate became wetter, increased rainfall would raise river discharge. This would give the river more energy, increasing vertical erosion and abrasion of the riverbed. At the same time, wetter valley sides would become saturated and unstable, causing more mass movement. The river would remove this material, allowing the valley to deepen and widen more quickly. That answer is strong because it considers both the river channel and the valley sides. Thanks for watching. If you found this presentation helpful, don't forget to like the video and subscribe to our channel for more content like this. Your support really helps us keep creating valuable information. We appreciate it.